We're really excited about having Rajiv here, so please give a round of applause to Rajiv Mirani. It's all yours.
Thanks, Dwayne. It's going. So in 2012, Amazon held their first AWS reInvent conference. I don't know how many of you were there, but if any of you were, some of you may have received this card that they were handing out. I built my data center in 5 minutes. This really powerful notion that you could go from scratch to having a full data center running with your applications deployed in just a few minutes struck a very powerful chord with many people at the conference, of course, and got us at Nutanix thinking as well. What would the equivalent be in the enterprise data center? How could we have a similar experience to AWS in the enterprise? And Amazon, of course, they built upon a trend that's well underway in the enterprise today. Everything they did was built on top of virtualization. And that's something that we have been doing for the last decade and a half in the enterprise. It's probably been the biggest single revolution in IT over the last 15 years. Virtualization was great for compute and for CPU and for memory, right? We took underutilized physical servers, we consolidated them into virtual machines, much better use of CPU and memory today than we used to have just a few years ago. What did not change, though, was fundamentally our storage and networking architectures did not change. We have faster speeds and feeds, and we have a few more features, but the fundamental architectures of storage and networking remain in most enterprises much the same as they were 20 years ago. And this has actually held us back. It has held us back because it limits scalability, it limits flexibility, it decreases the amount of scalability that we can have in our resource pools, and makes things much more complex than they need to be. That prevents automation. So if you look at how Amazon, and not just Amazon, Facebook, Google, LinkedIn, anybody who's really building large-scale data centers, build their infrastructure, they built on top of virtualization. Most of them did. But they completely changed the way they did storage and to some extent networking. They eschewed the use of any real intelligence in hardware. They use direct attached storage for direct attached disks for their storage. And they built all the intelligence into software. They built everything, most importantly, they built everything to be at scale out and to be resilient. So they can add capacity on demand to very, very large limits. And things can fail because you're building these things out of industry standard hardware, x86 servers, things do fail. Things can fail, applications continue running. You don't even know that a failure happened. To do this, they had to do storage and networking differently. But the net result was a very powerful set of capabilities, right? This is what the modern developer expects out of their infrastructure. They expect rapid time to market. So if I'm a developer today, if I'm starting up on Amazon, I don't have to talk to IT about getting a VLAN or getting a LAN provisioned. I browse an application catalog. I'm up and running in minutes. I don't have to guess what I need. I don't have to figure out that I'm going to need so much hardware 5 years from now because I'll have 10,000 employees instead of 5,000 employees. I buy for what I need today. I expand as I go along. These are obvious. I think everybody knows about this. But there's a few other things that we realize only after we start using services like Amazon, right? I don't have to worry about maintaining my infrastructure anymore, right? What version of BIOS is running in Amazon? What BMC version are they running? Are their SSDs patched with the latest firmware? It's not my problem. Somebody else takes care of that for me. Security updates come out, somebody else takes care of that for me. I'm not spending my weekends doing maintenance on my hardware. And there's continuous innovation. Amazon did not stop at just providing infrastructure to you. They've started building services on top of that. They have Elastic MapReduce, database services, Redshift, load balancing, everything coming out at a very rapid pace. Last year at reInvent, Amazon announced 500 new features in their product, 500 new features in a year. So that's what today's developers expect. And that's what they'll expect IT to deliver to them. So should we all just give up? Should those of us in the private infrastructure space just pack our bags and say that AWS is where everything's going to be? Well, it turns out that Amazon's biggest customers are actually leaving Amazon. Apple won't admit it, but they were using Amazon and Azure very significantly till recently, and recently started building their own cloud, this thing called Project McQueen, presumably named after the great Steve McQueen in The Great Escape. But it's not just Apple. Dropbox recently announced that they're building their own cloud. And actually, the Apples and the Dropboxes make news, but when we talk to our customers, even medium-sized customers are not finding Amazon cost-effective for them anymore. It's just way too expensive for them. They all want an alternative to that. And when we look a little bit deeper into it, what we see is that most enterprises have two kinds of workloads. They have elastic workloads. These are workloads that may run, let's say you have a sales report that needs to run once a quarter. Or you have a shopping application that gets a lot of traffic during the Christmas season, but is relatively lightweight the rest of the time. So there are these applications that need on-demand elasticity. And then there are more predictable workloads. Your email server is probably fairly consistently used. It's not something that gets big bursts of traffic at any given time. And what we see is about 25% of applications are elastic, about 75% are predictable. And for enterprise, for Amazon, Amazon's actually very good at elastic workloads. It's quick, it's simple, it's cost-effective. It's pretty good at predictable workloads, too. It's quick and simple. Turns out it's not cost-effective. Our model shows it's about 3x more expensive for predictable workloads than just running the same thing in your own data center. So let's call the Amazon stack the A block, right? What would the equivalent be for the enterprise today? Well, you could try building the same thing using three-tier infrastructure, using standard servers, using storage area network, storage arrays, and so on. It's not going to be quick. It's definitely not going to be simple. And once you factor in the cost of actually operating this very complex piece of infrastructure, it's not even clear it's going to be cost-effective. And that's where we feel the opportunity exists. That's where we feel the opportunity exists for someone to come in and build an Amazon-like infrastructure for the enterprise, an A block for the enterprise, if you will, that will be quick, simple, and cost-effective for private data centers. The reality is that most enterprises will end up with a balance of private and public cloud. For the elastic workloads, they will need to use public infrastructure. For the predictable workloads, they will run it in-house. And they will need the ability to move things back and forth, not just that it's not going to be siloed, that one set of applications is running here, another set is running here. You have to have the ability to move things back and forth. An analogy we use is, if you go for a vacation in Hawaii, you'll probably stay in a hotel. If you're lucky enough to be posted to Hawaii for a year, you'll rent a house. But if you're retiring in Hawaii, you'll probably go buy a house over there. You need a balance depending on what your needs are. And that's what we feel applies to the IT infrastructure as well. So what will it take for someone to build this Amazon for the enterprise? We need all the benefits that Amazon provides, the pay as you grow, the rapid time to market, simplicity and innovation that Amazon gives to you. You need all that. But you also need this ability to move things back and forth. You need the ability to balance renting versus buying. You need control of your data. You need to ensure that you meet all the compliance requirements your business may need. You need SLAs. For your most mission-critical application, Amazon does not really provide strong SLAs. To your customers, you need to provide strong SLAs. So your infrastructure has to provide that. And finally, you want openness. You don't want something. This is one of the big knocks against Amazon, is that they lock you in. Once you're in Amazon, you'll never get out. So if you're going to build this again in the enterprise, that's one thing you want to correct, right? You want openness and freedom from lock-in. So that's what we at Nutanix feel we have the opportunity to do. The foundations are already in place for us. We've built a full stack of infrastructure services. So we have storage and compute in the same platform. We already do a lot of the stuff that Ray talked about. So keeping data and CPUs close together. We have this concept of data locality, so that for any application, the data is kept on the same server as where the VM is running. And we automatically tier the hottest data onto SSDs, onto 3D XPoint, onto the fastest memory available, onto the fastest storage available. Colder data stays on magnetic drives, so you get the tiering automatically. We have all that built in. We've also spent a lot of effort in building automated operations, and not just automated. The key here is to make your operations non-disruptive. So you want more capacity. You add in more nodes to your clusters. You get more capacity, more performance on demand without having to bring down your applications. Same thing for upgrades. You want to do upgrades, you can do them in a rolling fashion while your applications are running with no downtime whatsoever. Pay-as-you-grow consumption. We don't quite have the per CPU granularity that Amazon has, but it's close. You can buy boxes with as few as 6 to 8 CPU cores in them. So we're pretty close to getting the pay-as-you-grow consumption that Amazon has. And finally, openness and choice we talked about, and built-in security. Security for us is something that's fundamental. It has to be built into the product. It's not a feature. It's not just like quality and stability are not features. Security is not a feature. Security is something that needs to be built into the platform, and we spend a lot of effort in making sure that's the case. So I'm going to focus on two of the technical foundations of the enterprise cloud. The first is what we call a single web scale fabric, a single fabric to run all your applications. And the second is the kind of automation, the control plane simplicity that Amazon provides. Let's talk about the single fabric first. So as I said, we have a converged stack, data and storage, data and CPU kept close together, hot data tiered into the fastest possible storage. But it's also designed to be scale out. So you can add capacity, add performance by adding nodes to your cluster as you go. You buy what you need today, you add stuff as you need. It's resilient, nodes can fail, disks can fail, and the system will continue to operate. Your applications don't see any disruption whatsoever. This is a similar fabric to what the big web scale guys do. And we feel that this architecture is suitable for every single application that's out there. There's this perception that hyperconverged is good only for mainstream virtual applications. Things like VDI, Splunk, Avaya, things like that. And it's true, we are a great platform for that. And we continue to improve the state of the art for these applications. We recently introduced the notion of file services in our platform. So not only can you have your VDI infrastructure hosted on Nutanix, you can actually have your department shares, your home directories, things that you traditionally would need a filer for, served out of the exact same storage as what's hosting your VDI infrastructure. But we've seen more and more of our customers using us for all kinds of mission-critical applications. People run SAP, SQL Server, Exchange on us. We have made great strides in the platform over the last year in terms of performance. We've actually had a 4x improvement in performance over the last year simply through software updates. That's the power of software-defined storage, is that without buying any new hardware, we give you continuous updates that improve the capabilities of the platform, the performance of the platform. For your most mission-critical applications, we have introduced all flash nodes so that you have guaranteed predictable latency for your applications without having to worry about whether the hot data was on magnetic or not. So all virtual applications run very, very well on Nutanix, which leaves one big class of applications. What about bare metal applications? Traditionally, this has not been a strong area for hyperconverged, right? Oracle, DB2, a few other applications like that, applications that require the absolute highest performance, where even the overhead of a hypervisor is not acceptable, or for licensing reasons, right? Oracle licenses were physical cores. A lot of people don't like to virtualize it because you're still going to pay Oracle depending on the physical appliance you're using, not the virtual appliance. So to support such applications, with our 4.7 release, which came out earlier this year, we introduced the notion of Acropolis block services. What we can do now is that on a Nutanix appliance or a Nutanix cluster, which is already hosting your VMs, we can additionally expose an iSCSI LUN out to your bare metal servers. So your bare metal servers can consume spare capacity on the Nutanix cluster, and they get all the same benefits that the VMs running on the cluster itself get. You get the same scale-out capabilities, the same resiliency to failures, the same one-click operations, one-click upgrades, without bringing the applications down. And performance is really, really good. What we have seen is we can get over 200,000 Oracle IOPS. This is not a random, this is not a benchmark. This is actual Oracle running on the system, 200,000 Oracle IOPS in a 2U appliance, which is more than most people need. So in addition to virtual applications, we can now run bare metal applications on Nutanix. But there's also a new class of applications coming, right? And that's containers. Many developers today, especially those developing cloud-native applications, start with containerizing everything, using a variety of different technologies. So how do you future-proof? How do you make sure that this wave of applications will eventually come to the enterprise? Probably in the next 2 or 3 years, you'll see much more interest from enterprise developers in using containers in-house. So to support containers, what we did was, again, with the same release, the 4.6 release, we added support for Docker containers right into the platform. You can use the Docker command line tools to provision Docker containers on the Nutanix appliance with no setup required at all. One of the big problems with containers so far has been that they're stateless. They're very good for things like web servers, which don't carry much state. You can spin them up and down. There's no backend state to persist. This obviously does not handle a bunch of real enterprise applications. And Docker just recently introduced a Docker volume API, which lets you create persistent volumes, attach them to containers, and the containers come and go. They can move around. The storage remains persistent. It outlives the containers if necessary. And we added support for the Docker volume API as well. So again, now we bring the same goodness of the Nutanix architecture to containers as well. This is shipping today with our 5.0 release, which is out very soon. We're also adding one-click operations, essentially the ability to manage your containers directly from the Nutanix API. So you don't necessarily need to use the Docker command line tools to manage containers. So all that's coming soon. So that's the fabric that we have built. It's good for every kind of application there is. The other thing we're very proud of is the effort that's gone into making our appliances very, very simple to manage, right? So when you're creating VMs, you think about VMs. You don't think about LUNs. You don't think about VLANs. If you want to turn on backup or disaster recovery for a VM, you do that for a VM. You don't have to worry, again, same thing, you don't have to worry about LUNs or anything like that. As I said, upgrades are seamless. Upgrades are non-disruptive. We routinely, on our development cluster at Nutanix, for a demo, I'll routinely show customers how I do a hypervisor upgrade at 3 in the afternoon on a Wednesday. There's like 600 developers. If something goes wrong, they're going to be not productive for the rest of the day. But we have become so good at this that I do this without hesitating at this point. So this is all good, but to truly make VM management invisible, we felt that we had to build our own runtime that was made for simplicity, made for automation. And again, I use the analogy with Amazon a lot, but it is an inspiration for us. We don't know what hypervisor Amazon runs. Every time I say that, somebody says Zen, but we don't actually know that what version of Zen they run. They forked off Zen 10 years ago. What they run probably has no resemblance to open source Zen today. We don't care. We don't care what hypervisor they run. Yet in the enterprise, we worry so much about which version of VMware ESX we are running, whether we have applied update 2 or update 5 or whatever, what it broke, which devices don't work anymore. It's not useful work. So to work around that, we introduced our own hypervisor last year, what we call AHV. It's the Acropolis hypervisor. Uptake for AHV has been pretty good. It's been more than we expected when we introduced this just a year ago. We have all kinds of applications running on it. Customers are running databases, VDI, big data applications. They're running OpenStack clouds on top of AHV. And we have built a pretty good partner ecosystem as well with Microsoft, Citrix, Palo Alto Networks, F5, bunch of really great partners who work with us on certifying their solutions for AHV. And in just over a year, we've actually got 15% of our customers already running AHV, which is quite a big swing in the amount of in the uptake that we have had for this hypervisor. AHV was built for being invisible, built for scale out, built with security in mind. But most of all, we also built it with application mobility in mind. We don't want people to be locked into our hypervisor. I'll talk a little bit more about this later. But one of the unique characteristics of AHV is that we actually make it very easy for you to move your applications between hypervisors and the cloud even. What we wanted to do was to make the IT administrator's job even simpler, though. VM management is very, very easy in AHV, but it's still something the IT administrator has to do, right? So typical IT administrator is getting requests from all the departments in the company, from engineering, finance, and all they're doing is, going to the UI, pressing a few buttons, allocating VMs and returning some login credentials to users. What we added was a capability where this could actually be outsourced to the end users themselves. The administrator defines quotas. He defines projects. He puts quotas on them. He specifies what operations people can perform under that project. He can specify which networks they can access. But beyond that, he now makes VM provisioning available to end users. They can create their own VMs. They can actually create their own containers as well. And as long as they're not exceeding their quotas, they can go ahead and just build stuff out on their own. At the same time, the administrator always has full visibility into what's happening. He can monitor things just the same as if he had been doing all the stuff himself. So really frictionless service delivery. I talked about making the hypervisor open. The entire platform's built with this in mind. So even though we have our own hypervisor with AHV, we believe you should be able to use any hypervisor. So we support, in addition to AHV, we support ESX, we support Hyper-V, and yesterday actually we announced support for Zen Server as well. So the 4 big hypervisors are all supported on Nutanix. So we've introduced features like cross-hypervisor DR, where you could have 2 data centers, primary data centers running one hypervisor like ESX, your backup data center is running a completely different hypervisor like AHV. Maybe you're doing that to save cost, something like that. We'll take care of all the translations for you. As your VMs are replicated from data center A to data center B, we will convert the formats, we will inject the right drivers in, and so on, so that you can easily move VMs between the 2 hypervisors. We also introduced a concept of one-click hypervisor conversion. If you want to try out AHV, you can start with an ESX cluster. Maybe in your test and dev environment, you feel comfortable trying out AHV. You can literally, with one click, upgrade, we call it upgrade, the cluster to AHV. We'll convert all your VMs to AHV format, again, inject the right drivers, bring them back up on the AHV cluster. You like it, you keep it on AHV. If you don't, you can actually move back to ESX as well. So one-click conversion back and forth. But one of the barriers we found for people actually taking this step and converting to AHV was that the tool chains are different, right? It's easy for me to say, hey, you can convert from ESX to AHV and try it out. But it's a new tool chain you have to learn. So what we did was, with our next release, the 5.0 release, we are introducing multi-cluster management right into Nutanix. So not only can you manage AHV from within our UI, which we call Prism, you can now manage ESX as well from within Prism. So you can get used to the stack before you decide to change hypervisors. And in the future, we'll have Hyper-V support as well. So any hypervisor supported. On the cloud side, we added support for the cloud platform services that Microsoft offers. Essentially, you get Hyper-V, System Center, and Windows Azure Pack, all installed from the factory, shipped from Nutanix to you, and deployment of CPS takes hours rather than days that it used to take in the past. We also introduced support for OpenStack. So we bundle Glance, Cinder, Nova, and Neutron drivers for you so that you can consume compute, storage, networking, and image services directly out of the box. And you can run any OpenStack distribution you want on top of that. We'll do the translation from the OpenStack APIs to the underlying AHV APIs. So you can run RDO, you can run Helion, you can run Mirantis, whichever distribution you want for OpenStack. Again, cuts down OpenStack deployment times by a lot. We've seen customers who've struggled with OpenStack for months and years, being able to now deploy it in a matter of hours. So that's the journey we are on, right? So we started with hyperconverged. For us, that's the basis for a lot of what we do. But to us, there's a lot more it takes to really build an enterprise cloud. We added a native virtualization. We added capabilities around machine intelligence. We've added file storage, container support. And we still have some ways to go. We still have to build technology around networking, around object storage, around really building an application ecosystem like Amazon has. But for us, the overriding principle is that we want to do this on your terms. We have to keep the simplicity of the public cloud experience when we bring the same thing to the enterprise. Our chief architect says, complex is competent, but simple is genius. And that's really something we really abide by. And the greatest satisfaction we get is when customers tell us how quick, how fast and easy Nutanix is, how they can do upgrades with no downtime whatsoever. So they're doing it from everywhere. They're doing it without spending their weekends on it. They're doing it from planes, from trains, from automobiles. It's one of my favorite shots on Tesla. Doing it while having a coffee. Essentially while doing anything, while cooking, while playing games. And my favorite, when they're not doing anything at all because the infrastructure just works. And this is what gives us the confidence that we really, really have a shot at building the AWS for the enterprise. We have a technical session later today at 12:20. Sam Hernandez is going to do that in the Sorrel room. So if you guys are interested in learning more, please attend that session. Thank you so much.